Welcome to Codecrafters, and in this video we are going to discuss some basic theory concepts of Java for beginners actually. So this video mainly deals with the beginner concepts, not any advanced things. So it's just a theory concept video, and let's get started. So what is Java? Java is a programming language. We all know this, but it's not just a normal programming language. It's a high level, general purpose, object oriented programming language. As we already know, Java is a pure object oriented language, whereas in C++, it's an extension of C with some object oriented concepts. But Java is a pure object oriented language actually. Yeah, and it's also the most secure language you can ever find, and it was developed by James Gosling at Sun Microsystems, and then it was taken over by Oracle Corporations. So now Java is actually the owner of Java is Oracle. Okay, now let's get into some features of Java, which is really important. You need to know this. So features, Java is simple, like not just secure, it's also known as a simple language. Why? In all other languages like C or C++, you have these concepts like operator overloading, pointers, and everything. And it's actually difficult to understand. But in Java, you don't have any other things. So it makes your life even easier when these complexities are not involved in this language. And it's portable. Java is known for its platform independence. Why? If you have a JVM in your machine, you can run Java on any platform, no matter whatever OS is running, you can run Java. That's why it's known as portable. It's platform independent, which means any application written on one platform can be easily ported to another platform. Where the platform here, it means the OS, like which OS is running on your system, be it Linux or even Mac or Windows, whichever OS it is. If you're written in one OS, it can be easily ported to another OS. There is no need of any other installation or anything, and it's object oriented. As I said, Java is a pure object oriented concept. So everything Java possesses, it's always in objects. It always in objects and classes. We will deal into objects and classes in a much later phase. And it's secured. Yeah. In Java, normally in other languages, in C or C++, when you actually write a program and compile it, it just compiles the program and you can run it. But in Java, there are two things which are happening. One is compilation, other one is interpretation. So first, a Java code will be converted to a byte code. The first step is compilation, that is just convert the code into a byte code. And this byte code will not be able to be a readable thing by human. And Java, as already said, Java doesn't use any explicit pointers, and it just runs the programs inside the sandbox to prevent any activities from untrusted sources. That's why it makes the program as virus-free, tamper-free systems and applications. So the last point is really important. Java does two steps, that is compilation and interpretation. So first step, Java actually converts the code into a byte code, and that byte code is interpreted line by line, and that's how you get the output. Okay, so first step is compilation, and then the next step is interpretation. I hope the features of Java is clear. There's all the other features. It's dynamic, distributed, and robust. So Java is dynamic. So what does it mean by dynamic? It actually supports dynamic memory allocation. Dynamic memory allocation means only during the executing time of the program, the memory gets allocated for the variables or arrays or whichever you create. So that's called dynamic memory allocation. Because Java has this kind of feature, the memory wastage is really reduced and the performance of the application or the program is really increased. That's a feature of main Java. Dynamic. Distributed. So what's distributed actually? Like in simple words, it can be said there are applications which is distributed application and which are used when you have a network facilities like TCP or IP protocol, and Java has those. So you can use RMI or EJB to make those kind of distributed applications. And Java is robust. Robust in the sense Java has a thing like even during the executing compilation or interpretation time, that's compilation or runtime. Runtime is known as the interpretation process. Okay. So during the compile time or runtime, Java can actually identify the errors. So it has a good exception handling thing. And also, as I said, the memory management system known as the garbage collector is a very good thing in Java, which makes the program as a really fast and secure one. And there is no memory wastage. So it makes the program like a good one. That's what I mean. And another one main feature of Java is it's multi-threaded. That means a lot number of different tasks can perform at the same time. So that's a main feature of Java. Using Java, you can actually make different applications. So some of the applications examples are mobile application, desktop GUI. GUI means user interface applications, and web-based application, enterprise application, scientific applications, gaming applications, and etc. So before we get into the programming part of Java, there are some main components of Java which you need to understand. Only then you will understand how programs work in Java. So what are the main components of Java? One is JVM, that's Java Virtual Machine, and the other one is JRE, that's Java Runtime Environment, and the other one is JDK, Java Development Kit. So what's JVM? JVM is an abstract machine. It's also called as a virtual machine because it physically doesn't exist. And it also is a specification which provides a runtime environment in which Java bytecode can be executed. As we write Java in normal English, which uses the programming syntax and everything, it needs to be converted into a bytecode, right? So for that, JVM virtual machine provides an environment for it. So it does only 4 main tasks: loads code, verifies code, executes code, and provides the runtime environment. So what does JRE do? JRE is denotes for Java runtime environment, right? So it refers to a runtime environment in which the bytecode can actually be executed. In JVM, it just provides the environment. It doesn't execute the bytecode. But in JRE, the bytecode is actually executed. So it implements the JVM and provides all the class libraries and other support files which are required by JVM, which uses them at the runtime. And as JR is a software package, it contains all the codes or all the files or the libraries which we need to run a Java program successfully. And now we can say that it's an implementation of JVM which physically exists. Next, we have the JDK. What's JDK? It's Java Development Kit. As it is a kit, you already understand that it's like a software kit. Okay, it has the software development environment which is used for develop Java applications and applets. It physically exists and it contains everything: JRE, JVM, and all the development tools which are used to run a Java program. So here's a small diagram of JDK, and inside JDK there will be JRE, and inside the JRE there will be JVM and set of libraries and other files which are required to run the program, and also development tools like Java. You will know its uses in the later part of the tutorial. Okay. Do you remember when I said Java is a platform independent language? And you know the reason why Java is a platform independent language? Because Java has bytecode. Bytecode in Java is the main reason Java is known as a platform independent language. Because as soon as we compile a Java program, a bytecode will be generated. So to be more precise, we can say that a bytecode is like a machine code in the form of a dot extension dot class file. The extension is dot class. So when a Java program is compiled, it will create another file that's called class file. Okay. We are source code, we are writing a source code. All the programs which we write is known as source code, and the source code is compiled. A new file will be generated that's known as a class file, and that class file is bytecode. So bytecode in Java is like a instruction set for the Java virtual machine, and Java virtual machine acts like an assembler. Let's say, as we already said, bytecode is machine code. Now we have a doubt, what's the difference between a machine code and bytecode? A machine code is written in machine language and the CPU will be running the machine code. Okay. But a bytecode is written in machine code, but still it's not a runnable code. It needs the interpreter to execute it. So that's the main difference between a machine code and a bytecode. This diagram actually says it clear. So we have a source code at first, and then we have a compiler. The compiler will compile the source code into a bytecode, and then we have the bytecode, which is a class file. Now we have the JVM, which has the instructions how to actually compile the bytecode into a machine code. Okay, and that machine code will be run and we will get the output of a program. I hope it's clear.